but I can't get hung up on that. I've got to move on. So I want to get the sockets soldered in there because it everything seems to be working. And then actually no, I take that back. I don't want to do that. I'll put this end one in so I can test the Ethernet card to make sure it works. And then probably, heck with it. I'll just put them all in. Hell with it. Put them all in, and then now that I know it chimes and works fine, and then we'll get the power supply rebuilt because it's one of those situations where it's going to need caps. I tell you, this thing was a royal pain in the ass to get apart. This is a different design than what I'm used to because the last two, the 2X and the 2CI I took apart was a different design. This one's from 92 and it's just different. But I'm going to have these low voltage caps, but I know I'm not going to have these high voltage ones. However, we've got these reefas that we need to take care of. so that's everything minus the floppy drive and hard drive. But I want to test things as I go along, right? So we'll grab that. Then we'll grab you. I don't have a battery holder for this, so we're just gonna deal with it. I guess that's just how that's gonna be. Alright, well, so now or never. No. That's a negative. That power supply is dead. Dead power supply. That is a no. Damn. After I put all that back together too. Well, crap. Well, it's worth a shot anyways. So power supply is no good. Oh, well, that's why it wouldn't slide in. Whoops. Alright, well, I didn't even hear it draw current. Squares on top. Yeah, that's right. Yeah. Yeah, it drew current. The light flickered. But she's dead. No good. Alright, well, we got some troubleshooting to do with that. We got trickle power. Yeah. So the trickle controller is dead in this thing. Either that or the power on circuitry is. It's one or the other. It's no good. So that power supply is dead. Which, this power supply was in unknown condition anyways. So it'll be interesting to try to figure out why it's dead. But it is dead. Alright, well, so much for that. I gotta remove this again, because that thing got bent out of shape. Yeah, That's what I get for not paying attention. Shields are an annoying pain in the bunghole. Alright. Well, put this board back in because I know it works. Okay, so we have a problem with this power supply. Time to do some troubleshooting. I don't have the pen out handy, but I'm sure I could figure that out. Let's see, trickle power is going to be probably one of these three here. Yeah. Well, we have trickle power. Yeah, 5 volts. Okay. I did a bit of studying this thing off camera, and the way this thing actually works is we have this green and white wire here. Green is the power supply, the trickle power. This white is power on. Okay. Well, trickle power is generated by that transformer here, and it goes through the rectifiers and all this stuff, and it snakes its way up to this green wire over here. Well, the white wire comes back through here, through this inductor. It's a filter choke, it looks like. Yeah, filter choke. And I want to say, yeah, that's definitely white. So the white wire goes to the filter choke, snakes its way through these two little black jumper links to this pin right there, which is here. So that is the power supply. If you snake it, it makes its way all the way around and eventually ends up over here. So it runs this IC, powers this IC. So there's a strong likelihood that this Aztec proprietary AS38 something is dead. It wouldn't be the first time I've seen this. Now, that chip you're not going to get. However, that is just a rebadged UC 3842, which you can get. So I'm probably going to have to order up one of those chips. It's a good thing I caught it now instead of later. I put a cap in backwards. I had to flip-flop it back the other way because it wasn't making sense. That cap is the VCC filter that goes to the 3845, or well, no, never mind, the 3842. And there's a transistor that turns on, which passes the 12 volts to this chip, because this 3842 has a minimum VCC of 10 volt and 16 volt on. It's right here. So we have 16 volt on, 10 volt off. But the 48, let's see, 48 and 45, let's see, 48, 38, 45, 8.5 volt on, 7.9 volts. So it's got different levels. So 3842 can go up to 100%. 4445 can only go up to 50%. So the only new chip I have on hand is the 45. I don't have any of the 42s. So that probably won't work. What I need to do, though, is I need to verify that that chip is actually getting VCC, because it could be one of these transistors that are bad, but I doubt it. I checked all of the resistors on the board. They're fine. I checked all the diodes. They're also fine. And all of these transistors statically check okay with diode check, but that's burnt me before. So I'm not going to roll them out just yet, but I have a feeling they're likely fine. I'm starting to suspect our 3842 died at some point in its life. This thing probably died a long time ago. And when it died, it was just cast aside, and well, that was that. So, And this was, I think, used, this came from the UK, so this was used on 240 volt AC. So, and then this is automatically adjusting for that. Now, the one thing I will say is this 3842, I'm pretty sure, drives this transformer directly. And there's only so much abuse that that's going to put up with before it just dies. And I think that's what happened here. Chase the circuit even more. So the drive output from the 3842 goes into these two transistors. This is a push-pull output transistor topology, which is helpful. I mean, the circuit already has it on its own, but in this one, it goes to this push-pull output topology, which then drives this capacitor. It's capacitively coupled. The output side of this cap, if we follow it, goes from the transistor through the cap, and then out these two components, and well, into these two components, which is a resistor, diode, and or parallel there. And it goes out, snakes around, which comes out this pin here. And that pin there goes right to the transformer. So the MOSFET array is transformer coupled, but the transformer is driven by these two transistors through this film cap. So if that film cap is open, we'd have problems, but that's not likely. I think we just lost this IC for some reason or another. So what we're going to do is steal that 3842 from this parts analog board. This one was sent to me years ago and was replaced. Knobs all busted off, and flyback I think is also shot on this one too. So it's a parts board. I'm gonna steal that out of there. Okay, new IC is installed. We're gonna check this thing out now. It's either gonna blow up. I don't have the relay installed, so I'm not gonna hear a click, but I'll know if something else is going on. Okay, so we are started up there. Make sure we have our standby 5 volts. And we do. Alright. Question is, does it actually start? Yep, I heard it. Yep, I can see it discharging. Well, that's awesome. I knew it. I love my intuition. That 3842 was bad. Well, let's add that to the shit parts list. Alright, here we go again. So that power supply should be fixed now, I hope. You know, I mean, who knows anymore? I mean, okay. Who knows what it's going to do under load, but we're going to find out. Here we go. Oh, there it goes. Just took a minute. It works. There you go. That chip was bad. And it was just intuition. I had no idea, but I also had an idea because the power supply is stone dead and there's no blown fuses. Your caps are replaced and there's no open resistors. That's why. Almost every single time. We're good. Oh, I didn't check to see if that light worked. It does. Yay! I have a light in the front. Yeah, she's lit up. Perfect. All right. Okay, what's next? Floppy drive. We have to service the floppy drive. And actually, this machine was missing its floppy drive, but I got a spare that came with all of these boards, so guess what? This is my last 1.44 megabyte drive, too. This is my last one, so I better hope it works, because if not, I don't have any spares. I got tons of manual inject drives from like the PowerPC era, but none of these These are getting rare and they're getting expensive. I do not have this SCSI cable. No. I'm kind of getting low on those, but that's not a big deal. Because this drive is probably dead anyways, but we're going to find out. Remember, this takes a few seconds before it'll become ready to turn on. It actually spun up. And oh my god, no way. You know, I'm gonna go grab a disc real quick. Give me 1 second. I do not have a monitor, but let's see. It's not even trying. It may not until it sees a monitor. Then again, remember this is still that 2SI ROM. One thing I do want to try, I don't know if this card's any good. It got thrown onto me, but we're going to find out. Ooh, that's so close. But I don't hear it trying to access the floppy drive at all. But this thing seems to be working. No, it is not even attempting to access the floppy drive. No, that has me somewhat concerned. One more thing I want to put in here. Let's just add some mystery to our mystery machine. Because I don't know if this card's any good either. Oh. It does not. No, it does not fit in there. Is that slot bad? Could be. Oh, I see. That'll do it. Oh boy. That is not gonna want to come out of there. This card has never been tested. I do not know if it's any good. Obviously, the new bus slot has a screwed pin here. Well, does that work? Yeah. That fits a little better. Anyways. Got a blinky blinky. At this point, I need a monitor, so I gotta see what this thing's doing. I'll be right back. Alright, while the plot thickens, I get chime and nothing. No video, no nothing. And I don't have the right 2CI ROM, so that's probably why. Alright, well, I've reduced it to the bare minimum configuration. Still no screen at all. There is a chime, no boot, no screen. However, if I press the reset button, so the video hardware is working. But we're not getting any initialization from ROM. And here's what makes it even more strange. The NMI button. it doesn't do anything after it gets beyond a certain point. But if I reset, then it will. So that's strange behavior. I'm not sure what to make of that. Alright, well, I put the ROM in this one, and it works fine. So there's no problem with the ROM at all. NMI button. Yeah, it's fine. So that rules out the ROM being our issue, so we don't need to mess with the ROM. Now I want to check this cache card and make sure this cache card actually works, because I don't really know. We're going to find out. But, yeah, so we can rule out the ROM at least. So we know, without a doubt, that we do not have a problem with ROM compatibility. So, that leads me to believe that one of these chips or something that I put on the other board is bad. Which could very well be because it was battery bombed. So it's possible one of these chips is dead. Don't know. The question's going to be, which one is it? And this is one of those scenarios where I need like a tech step. I don't have one. Wait a minute. So I'm eyeballing all these chips. And the thing is, if there was a problem with the board, we wouldn't get a good chime. Now, what chips could still have a problem, but yet still result in a good chime? How many Macs have we worked on? Well, we've got a couple. We have the SCC, we have the SCSI, which that's not the SCSI. We have the SCC, we have the SCSI, and we have the SWIM. These three chips can be messed up, but the system would still post. The VIA won't. You'll get death chimes or no chimes at all. The new bus chips could be bad, and it would still chime unless it's holding up the bus. But these are optional. The ROM doesn't need those. We have the ASC, which we know that's working. We know address decoding and all that stuff is working. So the address and memory controller chips are okay because we can see RAM, we can see ROM, we can see the SC, we can see all of that. So all of that's fine. We could be missing a clock signal somewhere. So I figured, well, it's going to be one of these three chips. So I checked the SCC here, and I'm not seeing anything. I checked the SCSI chip here, and I'm not really seeing anything. Now I checked the SWIM chip, and then I got one pin that didn't solder. Well, that's a problem. And then I checked these three. None of those really soldered. So that is also a problem. Yikes. Well, that would certainly do it. Because if it doesn't see the SWIM, it's never going to initialize. So let me fix that and try it again. Alright, that's a lot better. Still not the desired result, but now that I got the chip soldered, we're getting something. Yeah, I mean, we're getting something now. We didn't have that before. It means frame buffer memory is working. All that's working. But we're just getting a sad Mac. I don't know. I got to look that code up and figure out what it is because I don't know. Alright, so I have the designer, Max1ZZZ, doing some tests for me. He said that if the RTC is removed, it doesn't work at all. There's black screen, no chime, whatever. If you use the Rominator, which is what I got, you will get a chime and you'll get the F1 SADMAC, which is what I'm getting. I'm thinking, well, because remember we had to steal a chip off of another board, and I don't know. So I'm going to just check that real quick, because this is the only thing that makes sense. If I check the crystal, this crystal is supposed to be 32 kilohertz. I'm getting 6. No, that's not right. Something's up with that. Again, I could be chasing a red herring, but if this chip is running at the wrong frequency, the CPU is not going to be able to communicate with it because the protocol is going to be running at the wrong speed. Alright, so I can't stop myself from laughing. So I found that the clock connection is open from here to here. Figured, oh god, it's an open trace. So I'm looking closely with the RTC, and guess what? Guess what I did again? It didn't solder. It did not solder. Ugh. Really? Aboard this complex, you're bound to make mistakes. So that's two chips. The swim, now the RTC. Buh. All right, we're powered back up again. Let's see. Yeah, imagine that. All right, there's our clock signal. Let's see, we should have our 1 hertz pulse. Well, let's see, where are we? Yep, we do. It's working. Or at least that chip is, anyways. Now, question is the rest of the system? Well, I don't know. We'll have to see. Oh, man. So 2 chips didn't get soldered. Could have swore I soldered it, but I guess not. Alright, well, let's shut this thing down. I'm still having problems with these sockets. I can't get the RAM is being intermittent in those sockets. So that's becoming a problem. Alright. Ha 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 ha. Yeah. Wow. And the only problem with this board is just my mistakes. My mistakes. Didn't do that right. Didn't do the swim right. Now, these are still a problem. So, guarantee if I put those in, they are not going to work because these sockets are dodgy. I'm going to have to replace them. I was trying to not do that because I like these metal tabbed sockets, but yeah, so we're going to have to change them. Unfortunately. Holy crap. Let's try this again. Hey! Finally! Holy crap! Wow. Alright, well, unfortunately I had to play merry-go-round and I had one bad sim. So I need to find out, not only were the sockets kind of flaky, but I also was playing with a bad sim. So, alright, well, will it work or will it not? We don't know. Ooh, it's booting System 6. I didn't think the 2CI could run System 6. That could be the side effect to that ROM sim, but look at that. Look at that! It's working! Oh my god! Wow! That's good though. Alright. Hard drive's plugged in. Does the hard drive work? I have no idea, but we about to find out. Oh crap. It's booting from the floppy. I didn't want it to do that. Oh well, that's fine. It does. Wow. There. Whoa. That's not good. Let's see. When was this drive made? Let's see. Get info. I almost need to switch cameras. 1992. Modified 2001. Let's restart the machine. We just went to 32-bit mode. Or not. Wow. There might be a virus or something on that hard drive where it's just the file system is really corrupted. You know, I got a fix for that. Norton Utilities. Well, we'll see what happens here at least. Yeah, we're going to have to do a reformat for sure because it says the resource forks are corrupted on the system file, so that's done. Alright, well the flickering on the phone is annoying me with the monitor, so I'm just going to use my camera here. Anyways, so I did a unerase scan on the hard drive, and modification date's accurate, but the file names are not. So I'm starting to wonder. Let's see. I bet that hard drive. Let's see. I wonder what that does. I'm starting to bet that that hard drive is from a different locale, like it's Japanese or some other language that's not English, or this boot disk does not have the proper font to display that character set, because this was the days before Unicode and all of that. So I don't know what to think of that, but the more important matters though is that ratty little hard drive is working. I'm surprised. And more importantly, the motherboard is working. And if you haven't been able to tell, so's the ADB, because if the ADB wasn't working, the mouse wouldn't work. I love this mouse. It's like my favorite mouse. It's optical. It's ADB native. I don't have to have any little converter circuitry to convert USB to, it just works. But I'm looking, it's, you know what? It's looking for file saver data, which I know doesn't exist. So, well, it's not going to start up anyways, because we do not have a working system file. It's corrupted. Ooh, that tube is scratched. Oh well. To be fair, this was an e-waste monitor that I ended up recapping. But anyways, I didn't realize this machine would run System 6 either, but it does. I definitely need to get an OS installed on here. I'm debating whether I want to use the original hard drive or if I want to use a Blue SCSI. Actually, I might use a Blue SCSI because it has some tools and stuff on it, but also just leave the original hard drive in here until it dies, because screw it. I need to check the cache card to see if that cache card's any good, because I don't know. It was a mystery card that was in my parts bin, so I really don't know. But yeah, there's something definitely wrong with this hard drive. But the funny thing about this hard drive is it shows that it was created in 92, and well, it shows the modification date changed. Probably for me screwing with it on the disk. Whatever. This is 6.08. Yeah, everything's good there. So, and the funny thing is, this is the Rominator ROM too, because the Rominator is not the 2CI ROM. I'm pretty sure the Rominator is based off of the 2SI. But I don't know which machine came out first, if the 2CI or the 2SI did. Because I'm worried about it not having some of the hardware drivers in ROM, which might not matter with a later system software version because it's going to take over anyways. But the cool thing is, this thing is working beautifully. So I need to get an OS installed on here and all of that. I'm going to skip ahead because the video is not about installing the operating system and setting it up. It's more about building the hardware and then testing the hardware. So that's what we're going to do. Oh yeah, here we go. That makes more sense now. J1, this is the Japanese version. With, you can't read it, but that's kanji talk. 7CDJ71. So this is a Japanese installation of the 2CI. So this 2CI came from Japan. Now, unfortunately, it's like, well, we could save the system software. I don't know if it's been archived. But the problem is the system suitcase, which is the entire startup code of the entire system, is corrupted. So there's no fixing this install. It's broken beyond broken. Yeah. Ooh, it's got some cool stuff on here. Eyeballs. Yeah, there's some, let's see, Ether Talk. What is that? Sticky Click? There's some cool little programs in here. I don't know what all that stuff is, but click, there it is. I don't know. Yeah, it's not gonna open, but whatever. Don't know. Oh, here we go. We've got some stay here. I want to save some of these extensions because I don't know if this stuff is archived anywhere. Oh boy. Hopefully this isn't affected by like the sub 7 Trojan or whatever, because that was a real problem in its day. B hierarchy, there's the finder prefs. Alright, well, that's enough of that. Ah yes, the joys of keyboards. K works, but L does not. Oh, dang, that's a good keyboard too. Oh well. Oh yeah, there's a problem here because it sees, THEtech knows the 3 new bus slots are there, so it can see that chip. But the problem is it can't see anything in any of the slots besides video. I threw 2 Ethernet cards in there. It's possible 1 Ethernet card's bad, yeah, but 2 of them? I don't think so. For some reason, it can't see these slots. Not sure why. Alright, well, the board is back out of this thing, and I've gone over this so many times, but eventually your eyes start to go cross-eyed. So the new bus isn't working on this board. I did the wiggle check on the 3 PLCC chips to make sure none of those pins were loose, because remember we already forgot 2 of them over here, or they didn't solder down. So that's taken care of. So I figured, well, I'll check the new bus anyways. Didn't see anything there. It all looks good. So I'm checking the bird seed. It all looks good, at least until I get down to here. R103. Whoops. I forgot to solder U. Well, it looks like I tried, but it didn't bond to the pads. So, if we take a look at R103, where it is in the schematic, R103 goes to this signal here, which is an output enable signal on the new bus transceivers. That might be a bit important, so let's fix that. Alright, resistor patched up, card put back in here. I'm starting with the A-Rose card. Machine's fired up. Let's see here. We're back into THEtech, so we'll go into here. Still shows my 3 new bus slots. Scroll down. Ah, there it is. Apple Ethernet new bus card. Mr. Resistor. That's all it took. There it is. It's working. God. There. Now we can get this thing on the internet. Hopefully. Alright. This machine is finally working and together. Ethernet card's working. It's connected to my bridge. It's setting the clock. Everything is working as it should. So I ran this machine without the cache card, and those are my results. And then I ran the machine with the cache card that I put installed in there. It's some random one out of my parts bin, and that is my results. As you can see, the cache card is inching up the performance numbers quite a bit, and I'm not getting any stability problems, which means my cache is working fine. There's no bugs with the cache card. So let's see. There is, yeah, I mean, everything's good. We've got cache. It shows the MMU, shows all of my RAM. 512 by 384, which makes sense because I'm using a Macintosh IIci monitor. But it's all good. It's all good. So perfect. we're gonna go ahead and go with that. There's no more problems with the machine as far as I can tell. The internet stuff is working fine. It's showing the network, so if I do network time, I can pull that guy up and it's all good. The other thing I want to do is set the memory. I think it's already in 32-bit mode. I don't recall. It is. And then the other thing I want to do is there is a program I installed called PRAM Autosave. Turn it on. Let's see, I think it's on. On startup, on shutdown, save PRAM. Perfect. That way, because I don't want to put a battery in here, but because I think if I save all the PRAM settings and then I set the clock on startup with the internet connection, who needs a battery anymore? It's not necessary. So there we go. It's working perfectly fine. I've got no problems with the machine. Running System Software 753. We're good. Finally we can wrap this project up. I love it. I started on this project Tuesday, and is now Friday. It took that long to get this thing set up and working with lots of little issues in between. But you know what? It's finished. It's working. I'm happy with it. And we've got one Macintosh IIci back from the dead that would otherwise be destined for the trash bin. So if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. If you have a comment, please feel free to leave one. Until next time, guys, thank you for watching.